We previously talked about ways to define sets using either roster method or set builder notation. Interval notation is a third way we can represent sets, in particular when we're talking about all of the numbers in a particular range. The first thing we need to realize is when are we going to deal with less than or greater than, and what tells us the difference between that and less than or equal to or greater than or equal to. First, using parentheses means don't include this number. So this is when we have a less than or a greater than symbol. Square brackets mean include this number. This is when we have a less than or equal to or a greater than or equal to. So when we're dealing with interval notation, these parentheses and square brackets let us know what type of inequality we have. In addition, if we ever have to deal with intervals that go to infinity or negative infinity, these always have parentheses. Infinity and negative infinity are not numbers that we will be including. Instead, they're ideas, so they get parentheses. Now let's start looking at some particular intervals. Total, there are 9 different types of intervals that we'll look at. The first are things of the form a to infinity. What this means, this is the set of all x such that x is greater than a. As an example, we could consider the interval 3 to infinity. So this is the set of all x such that x is greater than 3. We can also graph these. So if here's 0, 1, 2, 3, we want numbers bigger than 3. So we put a parentheses at 3 and then shade to the right. In addition, a different notation to do these graphs is if we have the exact same number line. Sometimes you see an open dot on 3 to indicate that we don't include this number. And these are just different notations. These graphs mean the exact same thing. The opposite of this would be the interval negative infinity to b. This is the set of all x such that x is less than b. As an example, negative infinity to negative 1. This is the set of all x such that x is less than negative 1. If we want to graph this, we do still have the 2 different ways to graph. The first of which would be to put a parentheses at negative 1 and shade below it, since we're going below down to negative infinity. The other would be to use the open dot on negative 1 to indicate that that point is not actually included. And then we do the exact same shading. Our next interval, a square bracket on a to infinity. This would be the set of all x such that x is greater than or equal to a. As an example, negative 2 to infinity means the set of all x such that x is greater than or equal to negative 2. Once again, we have 2 different ways that we could possibly graph this. The first would be to put a bracket at negative 2 and then shade to the right since we want bigger than negative 2. The second, the open dot means don't include and a closed dot means include. So we have a shaded dot and we shade to the right. So this is our third type of interval. On the other side of that one, negative infinity to b with a square bracket. This is the set of all x such that x is less than or equal to b. As an example, negative infinity to 1 means the set of all x such that x is less than or equal to 1. So we go 0, 1. We want numbers smaller than 1, so we'll put a square bracket on 1. And then we shade to the left. And once again, you could use a closed dot instead of a square bracket. The fifth type of interval would be a comma b in parentheses. This is the set of all x such that a is less than x is less than b. It's the numbers in between. As an example, -1, 2. This would be all the numbers that are bigger than -1 and smaller than 2. If we try to graph it, we would put either parentheses or open dots on both -1 and 2 and shade in the middle. And these are the numbers that we would be considering. We could start to include endpoints. Maybe we have an open parenthesis on A and a closed parenthesis on B. This would be the set of all x such that A is less than x is less than or equal to b. So all the numbers between, but we're including our right endpoint. As an example, 0, 3. This would be the set of all x, so the set of all numbers that are bigger than 0 and less than or equal to 3. So we're actually including 3 this time. On our number line, we would have put a parenthesis at 0, a square bracket at 3. You could have also used an open and closed dot. And then we shade in the middle. And there's the graph. The next interval would be to switch these and include A but not B. So we want all numbers greater than or equal to A but less than B. As an example, -2 to -1. This would be the set of all x, so the set of all numbers greater than or equal to -2 but still less than -1. On our graph, we would have a square bracket at -2 and a parenthesis at -1. And once again, you could use a closed dot on -2 and an open dot on -1 and shade in the middle. We could also want to include both endpoints, so square brackets on both of these. The set of all x such that x is greater than a and or equal to a and less than or equal to b. As an example, the interval 0 to 1. These are all the numbers greater than 0 and less than 1. So we're considering all the numbers between 0 and 1, including 0 and 1. On my number line, we would use either square brackets or closed dots on both of these, and then shade in the middle. The very last type of interval is kind of an unusual case, and it's the case of all of the numbers. -infinity to infinity is just the set of all real numbers. The graph would just be the entire number line shaded. And it's important to realize that we would want to use parentheses here since we're dealing with infinity and -infinity. And this just says every possible thing could